Hello everyone, my name is Gautam Kanapurthy. I'm the head of product at Normalize. Normalize is a data-first cloud security solution. I'll do a quick overview of the problem space we operate in, our approach to the solution, and then dive into a product demo. As we all know, data proliferation has become quite a challenge for security teams with the increasing adoption of cloud and migration of data workloads into cloud environments. Add to that the explosion of AI and ML investments and adoption of CI/CD makes it harder for security teams to stay ahead of the activity around all their data and the changes to applications that also impact how data is accessed and who accesses the data. Today, if security teams want to answer basic questions such as where do I have all my sensitive data? Do I have any shadow data stores, abandoned data stores? Do I have overprivileged users? Do I have sensitive data that is actually at risk of breach? Or even, am I complying with regulations? All these questions are quite complex in a world where data is spread across IaaS platforms, data platforms, on-premises databases, as well as SaaS applications. So Normalize has set out to solve this problem to provide a holistic data security solution supporting end-to-end the use cases including data discovery, data classification, access governance specifically around data, risk detection and compliance, and give the security teams a holistic picture of their data security posture. So Normalize is a completely agentless cloud-native platform. So the way we build our solution is to be able to connect to your cloud environment seamlessly and get visibility into the data stores that are all deployed. The key thing to note is that Normalize doesn't need the customers to tell us which data stores to monitor. We will automatically discover all the data stores. We connect to the data stores and look at the raw data and identify all the sensitive data that is sitting inside these data stores. And lastly, perform a privilege analysis, looking at all the IAM configuration, parsing through all the roles, and understanding who has access to what. All of the inventory and configuration and context that is gleaned by Normalize is saved in a cloud infrastructure graph, which makes it easy for us to analyze all the relationships within the resources across all the cloud environments and help identify what are those attack paths that are putting your data at risk. Once we have a prioritized set of risks, Normalize also has built-in automation to feed into your existing workflows. So you could either notify teams or trigger existing workflows via ITSM tools, so a remediation action can be taken right away. This is a high-level architecture of the platform. We can dive into the product now and talk a little bit more about it. But the key thing to note here is that because it is cloud-native and very straightforward to set up, customers can get started in less than 10 minutes from the onboarding and then start scanning and getting visibility into their cloud data environments. So let me start the product overview with a quick walkthrough of the onboarding. Normalize today already supports a variety of cloud platforms, including AWS, GCP, Azure, and Snowflake. I'll walk through an example of how you would onboard an AWS cloud account just to be representative. As you can see, the onboarding for AWS requires the customer to just enter an account ID, and that's really all we need. When they go to the next step, we generate a CloudFormation URL that will take the customer to AWS console, and they just have to press done, and the onboarding would be complete. All we are doing here is effectively creating a role for Normalize in the customer's cloud account, so we can use that role to do a read-only inventory discovery on the customer account. Normalize does support additional options. If customers have standardized on Terraform, you could onboard via Terraform. If we have enterprise customers that are standardizing all their accounts under a parent organization, we can onboard the parent and discover all the child accounts as well automatically. But as you can see, it's a straightforward process, less than 10 minutes from onboarding. And once the cloud account is onboarded, we do the automatic discovery of all the data stores and assets within that environment. Data stores includes things like unstructured data stores, S3 buckets, EBS volumes, Azure Blob, for example. It also includes structured data stores like RDS, Redshift, DynamoDB, MySQL, and so on. We also discover data sitting on EBS volumes in your cloud environment, as well as databases that are deployed manually. For example, think of an Oracle deployed on an EC2 instance in the cloud environment. So the coverage is exhaustive to discover all kinds of data stores that are running inside your cloud environment. The assets that are discovered include things like VPCs, Lambda functions, compute instances, IAM configurations, roles, and users as well. The core hypothesis underneath this is that to really do data security and understand a holistic view of the data security posture, we believe it is not enough to look at data in isolation, but look at data in context of other resources, the upstream users and IAM configurations, as well as resource configurations. So we're not missing out on any risk that is created because of the upstream risky resources. After the step one and the inventory is completed, we do connect to the data stores. So Normalize can give you at a glance an understanding of how many of your data stores contain sensitive data, how many users and resources access that sensitive data, and how many risks are associated with that sensitive data stores. We realize a lot of enterprises have hundreds, if not thousands, of data stores. So the classification by risk profile here that you see helps security teams prioritize and focus on data stores that have their most sensitive data. So let's dive in a little bit and see what you get from Normalize with all the data scan and the cloud scan. As you can see here, this is a full inventory of all the data stores that are being monitored by Normalize across all your cloud accounts. You have full metadata on what exactly is that resource, how is it configured, which region it belongs to, how much volume of data exists. And you also have an understanding of all the data elements that Normalize has detected in that particular data store. In the case of structured data stores, you get visibility into all the databases, tables, columns as well, and the type of data elements that we've discovered. So it is very easy for a security team to basically go in and say, hey, show me all the columns that have sensitive data, for example, an email address or an SSN. As you can see here, very quick to get that information. So you know exactly the kind of information stored in different locations in your data stores. Let's dive a little deeper into one of the data stores. So let me pick the S3 bucket over here. This S3 bucket has about 37 MB of data. I see the risk profile is high. The likelihood and impact of the risks associated with that data store are high. I also see the data elements. I have some domain names. I have some PII in this particular data store. I also see a monetary value associated with it. Normalize calculates the monetary value to represent what the financial impact would be on the enterprise if this data store were to be breached. And that is based on the type of data we see, how much of that is actually sensitive, and volume of data that is sensitive as well. And we arrive at that monetary value calculation. On the configuration front, Normalize captures all the configuration that is actually set up for that particular data store. At a glance, you can also get metadata around the exact file types that are being stored in that particular data store. We do pull in tags as well. So if the teams that are creating this data store are tracking any business context to say, hey, this belongs to so-and-so application, this is the marketing data, this is internal data, that is all tracked and available within Normalize for security teams as well. And security teams can create their own tags to say, this is reviewed, for example, or this is higher risk, or this is not something we need to chase down. So custom tagging is available as well. And here you can see the number of files and objects in that S3 that actually have a certain type of data, and the number of sensitive records, meaning if there are multiple entries found in an individual file, all of that is available here. So do you understand how much volume of sensitive data exists? We do capture something called as a snippet. A snippet helps a security analyst to understand whether the classification that Normalize has made is accurate or not. In this particular example, as you can see, we have a PDF file, and there is reference inside the PDF file to an individual who is a professor in a particular college. But the sensitive data element there is an email address and the person's information. By looking at the metadata before and after the sensitive data element, I can have a higher confidence that this is some kind of a personally identifying information rather than a false positive. And the sensitive data element itself is masked. So even the security analyst looking at this for confirming it doesn't get to see the raw data, but they get to see the context around it and validate Normalize's classification. So a quick way to validate the classification instead of blindly taking what Normalize is providing as data classification here. So now let's look at all the access details that we are able to extract for this particular data store. As you know, in a cloud environment, there's many-to-many relationship between users and roles to policies to policy statements. So it can get quite daunting for somebody to look at all of that manually and lay out which user has access to what data store. So we actually normalize all of that configuration for customers and give them the end result of who are all the users that are set up with access, what kind of privileges do they have as part of this configuration, how long have they had access, and when did they last access. So at a glance, we're able to say there are users that have had access for many months, but they've never accessed it in a long time. So those would be the obvious candidates to revoke or adjust the privileges and make sure you have the principle of least privilege enforced across your environment. And Normalize does this in a pretty exhaustive way. It's not just users. We also give you a similar view of roles. So you can understand, are there roles granting excessive permissions, or are there dormant roles that nobody is actually using, even though they've been available for quite a while? We also look at resources that are accessing the data. As you can see, there's a bunch of Lambda functions here that have a read access. So beyond users, it is helpful to understand for security teams what are all the other entities that are also touching the data to make sure nobody else has excessive privileges. We do call out external users and external roles separately. So these would be cross-account access where a user or a role that is outside the account in which the data store resides, but they're still accessing the data store in a different account. From a security standpoint, it's good to review and make sure that the cross-account configuration is set up for a good business reason. So now we've looked at the resource configuration of the data store. We've looked at the data classification to assess what kind of data is inside that. We also now know what are the different access privileges available for all the users on that data store. And we put all of that together to identify what is the true risk posture of data sitting in this particular data store. Let me walk you through one example here. This particular risk is talking about an EC2 instance with public access, meaning the EC2 is available outside the environment for somebody who doesn't belong to the enterprise. It has an access to an S3 bucket containing sensitive data. Historically, cloud security tools, which are focused on infrastructure, have only looked at the first piece here, which says EC2 instance is publicly available. A security team may go in and say, I have a business critical application running on this, so I need this instance to be available and accessible from the public internet, and they may close out the alert itself. The S3 bucket itself may not trigger any alerts because the configuration on that bucket may have been done right. It is not publicly exposed by itself. But in reality, what's happening here is the sensitive data sitting in this S3 bucket has been exposed to the world because of the configuration and how the EC2 instance is able to get and assume a role and access this S3 bucket. So we're putting together the context we have on the resource configuration, the identity and access IAM configuration, as well as the data classification together. And this is fundamentally one of the core differentiators for Normalize, is how we put all the context we have, not just about the data in its isolation, but also about the upstream resources and users to figure out what is exactly the attack path. Is there a potential for this data to be breached, and give you a more accurate picture of the data security posture. And this also helps security teams go and prioritize the alerts that are associated with their most sensitive data, rather than chasing around a lot of alerts that are primarily to do with configuration, but don't necessarily expose your data. There's quite a few examples here as well where we are looking at sensitive data, but combined with a risky user, potentially. In this case, we are looking at an IAM user that has more than one active access key, which is not usual. And for all the risks that we are highlighting, we also give guidance on how do we actually address that risk. In this particular example, you have information on what somebody needs to do in an AWS console to remediate this risk. You also have access to what are the exact commands that somebody has to run on the AWS command line to remediate this risk. Every risk has a few actions available. So the security analyst can say, I want to ignore this because this is my internal data. This is not something that is confidential. Or they may accept that risk because there is a good business reason for this configuration to exist in such a manner. They can add some justification for future tracking and move on. Or they could notify somebody else on their team or a different team via email or Slack or through a ticketing system like Jira and assign that issue for somebody to go resolve it. We've also built something called as an automation. So security teams do not have to chase down every individual alert separately. If there are existing workflows that can be that are established already based on the tags that we pull from the cloud provider, based on the type of risk, or based on the account, or even based on the specific data store itself, or any combination of those four, you could create a rule and say, create a Jira ticket every time you see this. So for example, if your S3 bucket that has sensitive data is open to the world, in a production account, always create a Jira ticket, assign it to the DevOps team, and with a certain priority, so it gets fixed right away. The guided remediation that we saw earlier about how to actually fix will be available in the ticket as well. So whoever is picking up the ticket, they don't need to start their investigation from scratch. They actually have access to all the context that Normalize is providing, so they could quickly go run the commands and close that out right away. A couple other things I wanted to highlight in the product as well, starting with identities. We looked at identities in the context of a particular data store, but the same context is available across all the accounts that Normalize is monitoring. So for a security team, if they want to understand what are all the different identities that exist across my cloud environments, what do they have access to, and are they actually using it? It's consolidated as an identity inventory for you, so you can understand all the users and potentially look at who are the users that have access to the most data stores, for example, or look at all the roles that have been set up across their environments and see which are the most permissive roles that are granting access to the most sensitive data stores across your environment, readily available for you. And this is continuously monitored, so there is no manual upkeep for this process. Similarly, at a more granular detail, customers are able to look at a user and a data store level to say which user has access to what data store, what kind of privileges, and finally, when did they last access. So imagine an audit happening where somebody needs to prove that only a small set of users have access to S3 buckets with sensitive data or RDS with sensitive data. This would be a quick way to do that and download this and share it with the auditor as evidence as well. Normalize is built off of a graph database where we gather all the context we have about the resources and are able to establish the relationships across resources. So the same insight is available for security teams as part of the visualization in the product. So as you can see here, I can quickly identify if there is an entity outside the corporate environment, what resources can they actually get to, and also look at all the downstream dependencies. So in this particular case, I see somebody outside the company be able to get to an EC2 subnet group. I want to understand what are they now able to access because the EC2 itself is accessible. I see some roles that are connected to this particular EC2. I want to dive in a little further, and I see a role called S3 access with EC2 that is opening up access to a whole bunch of data stores across my environment, and not just any data stores, but data stores that actually have the most sensitive data as represented by the numbers in red. So this is one example of what we call as an attack path. Even though the data store itself is configured properly, because of the risky resources around it, your sensitive data is exposed. In every organization, there may be many such attack paths. To really identify those at scale and prioritize them for customers, we built something called as a query builder. All the context and configuration that we are gathering and all the inventory that we've identified is available here in the query builder for customers. And they can quickly build any query to look for activity of interest across the environment. So in this case, I want to look for data stores that are being read by a certain role. I only want to look for data stores that actually have sensitive information within them. Customers don't need to learn any new query language. Everything is visual. They could just build relationships here and run a query and understand if there is anything that is of interest to their criteria that is matching in their environment. If this is something that customers want to run periodically, we could actually convert this to a custom risk signature. This becomes a proprietary check that we perform only for this particular customer, but it happens every time Normalize runs a risk scan in the customer's cloud environment. So customers can build off of an existing risk signature that Normalize provides and customize that and make it their own signature as well, rather than starting from scratch. So hopefully this was a good overview of the Normalize product capabilities as existing in the product today. To summarize, I wanted to call out the key use cases that we cover already. Data discovery is exhaustive, covers all kinds of data stores, including structured and unstructured, as well as cloud native and those that are deployed by you on your compute. Data classification looks at the actual raw data, not just object names and file names, looking at the raw data and classifying that for you to give you a better picture of your sensitive data. Access governance, again, looking at all the complex configuration, giving you the end result of which user has access to what, and also looking at database level roles as well, so you understand beyond just IAM configuration down to the database level, which users have access to that data. And then risk detection, where we put all the context we have gathered based on resource configuration, identity, and classification to give you a more accurate picture of your data security posture. And finally, compliance, where we can highlight which controls a particular risk is actually tied to and what risks do you need to address in order to be compliant with some of the known benchmarks that your organization may care about as well. Thank you for spending the time to learn about Normalize. I did want to call out that Normalize is available as a freemium offering. You could go try out our product for free at normalize.ai/freemium.